So, we are right on time, and that's basically the main reason for why I say we start really, really quickly, because otherwise they might move the session yet again, because they already done that a few times, a couple of times to be more specific. So welcome everyone to How Far Can Serverless Actually Go? How did you like ITCamp so far? All good? Better than last editions? Best one yet? Awesome. Let's give a round of applause for our sponsors, but most importantly for the organizers for putting together such an awesome event. Thanks so much. Probably the least important slide of them all is this one. For those of you who don't know me, I'm Alex. I'm one of the passionate Azure MVPs, and that will be your host for roughly the next hour or so in talking to you about serverless in terms of Azure, and most importantly, server functions. So, before I deep dive into the conversation, I want to tell you 3 stories. These 3 stories have to do with numbers, and it would be awesome if you remembered those numbers. The first one is 1 million. So this story actually has me in it a few months ago, when I was in a cloud panel at a very similar conference in Europe. Basically, we were discussing about the cloud, and most importantly about IoT. And at some point, we concluded that it's not going to be too long until we eventually will have computers all over the place. And when I say all over the place, I literally mean all over the place, like in shoe heels, for example. Why? I don't know. Right now, I have no idea why that will be, but it will make a lot of sense in a few years. And it's actually widely accepted that by 2020, only 3 years from now, we will have 1 million devices coming up online every single hour, which is a staggering amount of time. So maybe by 2020, it will just make a lot of sense to have a computer in your shoe heel because it might vibrate, especially for women, and sorry ladies for saying this, it will vibrate when you pass along a shoe store with discounts. Maybe it will just measure the weight you're gaining while you're eating, because some people have this misbelief that they are losing weight while they're eating and walking at the same time, which is not true. Maybe it will just locate you wherever you are and things like that. I don't know. The second story, though, but this is an important number, and I would like you to remember this number. The second number is 12. 12, apparently, is widely accepted as the average age of the top 500 companies in the world by 2020, only in 3 years from now. Why is this important? It might not sound that impressive, especially for those of you guys who are still in your 20s, because this is half your age, right? It's very important because of the next reason. Right now, the top 500 companies around the world consist of companies such as Apple, which is 41 years old, Microsoft, 42 years old, Accenture, which happens to be one of the sponsors, over 60 years old, IBM, International Business Machines, 105 years old, M, 106 years old. So having the average age of 12 by 2020 literally means that companies which will end up being the top 500 companies around the world will be startups. They might not even exist yet. So in other words, you guys here in the room may be the founder of the next top 500 company in the world, and they literally mean that. What do you have to do? Well, you got the first thing right, which is attend my session. The second thing you'll have to do is give me a 5-star feedback, and that's good. You're on the right track. So this is an important number, and it's really important to remember this. And the third number, the third story, has to do with 60. 60, apparently, is widely accepted as the percentage of the overall computing which will happen in 8 years from now, by 2025. Why is this important? Because when you think about computing overall, that includes your mobile phone, your tablet, your smart TV, your everything, right? Everything which is around you. If 60%, which is the majority of the overall computing power in the world, will happen in the public cloud, that's a staggering amount. Why? Because only a couple of years ago, we were still finger-pointing Microsoft and Azure and other companies like that for having a lack of security, for not trusting them because they're US-based and so on and so forth. So in 8 years from now, almost everything which is server-based will happen in the public cloud. Now, let's see what this has to do with serverless. Most importantly, I strongly believe you're here at this session because you want to learn about serverless. And that's an awesome thing because serverless is getting a lot of traction nowadays. Most importantly, if you look all over the press and the newspapers, you see serverless everywhere. Right? So it's a no-brainer that serverless is a hype word and will get a lot of friction. Forget about IoT, forget about mobile, forget about Docker containers and things like that. This is, in my opinion, the future, and all the others are just a path towards the new leap in cloud computing. These are native cloud applications. And I also strongly believe that by the time I'll most likely be a grandparent, let's say, a grandfather, I'll end up telling my kids not only bedtime stories, which include Cinderella and Peter Pan, but also bedtime stories, which will start with, long, long time ago, there was a serverless, a cloudless world where you had to buy a shiny new server, and it took weeks or months, just like Ben Armstrong said yesterday on the keynote, it took you weeks and months to actually buy a shiny new web server if you had a good IT team. Now, virtualization came along roughly in the late 90s, in the early new millennia, and what it did, it basically increased the high-density concept. We had no longer a problem in terms of capacity, because you can virtualize multiple environments in the same underlying infrastructure. And that was just a next short path towards the new leap, which was IaaS, infrastructure as a service, in the cloud world. You all know what that is, so I'm not going to mumble too much about it. But then again, we realized at some point, you know what, we don't want to care about managing and maintaining infrastructures, whether they're in the cloud or on-premises, doesn't matter. What's the next leap? Well, obviously, platform as a service, because you want to blame Microsoft for ransomware, not want to be responsible by yourself for WannaCry, for not archiving your data frequently enough. And there is still a problem with platform as a service. If you attended ITCamp, and especially my session a few years ago at ITCamp, and I'm quoting now, I used to say, cloud allows you to have crazy scaling capabilities, and I end my quote. And that is correct. I still stand correct. But there is a small caveat. It is not near real time. It's not even real time, not even near real time crazy scaling capability. Or more specifically, it does take time when you want to scale to your application to multiple instances. There might be a dragger somewhere, a slider, you just have to drag it from left to right or whatever, so that you can get from one instance to tap to 10 instances. And that's cool. But the truth be told, it still takes a few minutes, a couple of minutes or 3 minutes for all the web services to be provisioned, load balanced, and actually process your requests. What happens through those 2 or 3 minutes? You lose customers. When you have like Mark Zuckerberg tweeting about your application, and all of a sudden 1 million requests come through, well, surprise, your application will crash, at least for 2 minutes. So how do you solve that? With serverless. Because literally serverless is there for you to completely forget about any infrastructure altogether. Like think of your C# code. How many of you are C# developers, by the way? Awesome, great majority. I love C#. So, of course I love C# because everybody raised their hand. So here's the thing. The one way to use serverless in Azure right now is take the plain text, like a text file, copy it over to Azure, and let it do its job, compilation included. You don't care about serverless in any way in those terms. So thinking about serverless and crazy scaling capabilities, it might sound like marketing, and I do admit it mostly is marketing up until now, because there still is one limit. Guess what it is? It's your bank account, because it doesn't come cheap. So if you're not making any money out of your application, well, lucks aren't really on you in those terms. But anyway, serverless, I forgot to point one thing out, and that is I hate the term serverless, because it's a marketing term. But not only because of that, serverless basically implies that there are no servers. But that's a lie. It's almost like saying developerless software development. Like literally, there will always be an Indian writing crappy code, right? That's software development for the next 50 years. Serverless still implies the use of server. But the thing is that servers are, servers are completely abstracted away. You don't care about anything in those terms. It's event-driven, which literally means your application only runs when it has to run. And because of that, billing is super easy. Like if your application runs for 1 second for the month, you pay for 1 second, which is nothing. It's the subdivision of whatever cents in US dollars. So it's almost nothing. If it runs for a full day, you pay for the full day. If it runs 24/7, you pay for it 24/7. There's no warm-up time or anything like that. It's awesome. It's super cool. So as I said, serverless is awesome. There are a lot of reasons for why you could love serverless. First and foremost, it's reduced time to market. And this is the main reason for why your startups, the companies you will found eventually, will end up in 3 years being one of the top 500 companies in the world, just like I said in the beginning of my presentation. Second and foremost, it reduces your DevOps. Honestly, how many of you are DevOps here in the room? Raise of hands. Oh, great. This is so awesome. So literally, what are DevOps doing all the day, besides watching their favorite TV shows? They just make sure that servers are in the desired state, right? They might use desired state configurations. They will template the infrastructure out. They will do crazy things like that. And your application will fail eventually. Why? Because there is a mistype or a typo in a file name. That's just crazy. Those things should not exist if you ask me, right? And serverless, at least in Azure Functions, completely reduces the need of a DevOps, because what you end up doing is configuring continuous integration and continuous deployment. That's it. A few clicks and you're done. Easy as that, easy as pie. Now, it also helps you completely focus on the business logic, because you write your application, that's it. You don't worry about anything else. Now, this might sound like too much candy right now. You're almost going to get diabetes because it's all advantages. But as a software developer, there is one other thing I love in terms of Azure Functions. So let's see what Azure Functions is about. Well, first and foremost, it's a way for you to publish your code, whatever you like. So you're here C# developers. If you write Python code or PHP code, that's still good. You can publish your code in Azure Functions, and Azure Functions will run it, period. It doesn't worry about which version of .NET Framework are you using, which version of .NET Core are you using, which version of Node.js are you using. No, you don't care about that. There's a minimum requirement, and that's it, right? Most importantly, though, it responds to any event. Like, that can be an HTTP trigger, and then your Azure Function app will act like a web server. It can be a blob trigger, and then you just have a workflow like it used to be in BaseTalk or Logic Apps. You have a workflow because a blob has been copied over to an Azure storage account. It can be whatever you want, and I will show you a few demos which are pretty impressive if you ask me. But most importantly, as a software developer, there is another advantage, which comes from the fact that you don't know and you don't care about your servers, which is this thing over here, no runtime optimization. Like, we are right now spending so much time after we published our code on optimizing the code because it consumes too much memory. There is no concept of a memory. That's abstracted away. We spend so much time on the fact that our code consumes too much CPU. We don't care about that anymore. So you basically completely minimize your development times because you normally don't care about the runtime optimization altogether. Sounds good? Awesome. So, how many of you, let's do the raise of hands again. How many of you are C# developers? How many of you guys who are C# developers, keep your hands raised, were ever excited by anyone telling you you can use your same service in Java as well? Come on, let's be honest. If I'm a C# developer for the past 16 years. When somebody told me that for the same service you have been using for the last decade now runs on Java or PHP or Python, I was like, I don't care about that. I'm already proficient in C#. Why would I learn something new? However, it's completely different with Azure Functions, because the way you will end up writing your function, one of the best practices is for your function to do one thing and one thing only. Your function app, however, will have multiple functions within it, which literally means that when you will start developing your function, you'll literally develop a microservices application. The same thing people have been praising for the past 2 years or so, the microservices architecture, Docker containers, things like that, so on and so forth. Each function does one thing, so that's a microservice. Why is this important? Why is this thing, the polyglot nature of Azure Functions, though, important? Because you can end up choosing the best proficient people, like your DB admins. They will most likely use PowerShell. I'm a software developer. I hated when I had to learn PowerShell, and I'm still not so good at it. I don't believe myself as being proficient in PowerShell. However, I'm very good with C#, so I can write the best business logic of my application. But then a UI developer, a web UI developer, who only knows and only wants to use PHP can work on the function which responds to HTTP requests with the web UI, and he'll use PHP. So within a single application, you can as well have PHP, C#, PowerShell, command batches, Python, or any other crazy programming language you can use, which literally means you literally reduce your time to market because you don't have to learn anything new. And this is why it's so important for Azure Functions to be polyglot. Impressed? Good. You're almost mind blown, aren't you? Now, the way a function looks like, and it's good that you're C# developers here mostly, is something like this. One of the strange things you will see here are the attributes themselves. for example, you're going to end up decorating one method with a function name attribute. That's like the entry point of your console. In a console application, you have a program CS main entry point. This is sort of the main entry point for your function. And each function, each main entry point, will always have a bunch of attributes which will represent your triggers. There is a binding done underway, because remember, I told you that you can also copy text plain text over to Azure Functions, and the Azure Function host will have to somehow parse the text. It's this function JSON thing over here, which literally defines towards Azure Function what exactly it will have to look for. Like, there is a parameter called rec, and it's of type HTTP trigger. So when a new HTTP request comes in, you have to do this. So this acts like a web server right now. Then you have multiple input parameters. You might also have output parameters. Like this guy over here, for example, is a JSON object, which has a direction of out. So it's an output parameter. Pretty easy, isn't it? But the interesting thing here, because my output parameter is not going to be an HTTP response, it will be whatever the function does, a queue, a message queue. What's interesting here is that I don't end up learning how Azure Storage works in terms of queues. I don't end up instantiating an Azure Storage context, a queue client, or anything like that. I don't have to learn the best practices of yet another API in Azure, and so many new APIs come out each and every single day, or every week at least, right? So I only specify, hey, there's a queue. The name of the queue apparently is AI events 1. Just use whatever connection string I will define in whatever other file, and that's it. Whenever I will type in my C# code event output 8 sync, it will know exactly what it has to do because of the runtime. Isn't that cool? Now, as I said earlier, the best practices include things like, number one, your functions should always do one thing and one thing only. They should be idempotent, meaning that no matter how often you run the function over and over and over again, it will always do the same thing. But this is the function. So remember, a function app will have multiple functions, most likely in a production workload. And lastly, functions should finish as quickly as possible. Because this is mainly because of pricing, if you ask me, but also because there is a timeout of 5 minutes. So when you're being billed by the seconds your functions execute, right? So it doesn't really matter whether there's only one request to process and it takes 1 second, you're being billed by 1 second. If 1 million requests come in right now, you don't have to scale your app, because your app and your system can already process 1 million requests. That's what Azure Function is, and it's pretty impressive. And honestly, this is the main reason for why I think it's the future. Now, want to see a demo? A cool demo? Awesome. The first thing I will do is I will open up the Azure Portal. And within my Azure Portal, within whatever subscription, I already pinned one of the resource groups. Let me open up this AZ function RG resource group I prepared earlier. I did this obviously because it takes a little time, like a few minutes, for the Azure Function host to actually run. And I specifically and selectively chosen the best name of a function ever, which is my own name, obviously. No better name ever. And what happens when I click on that guy is that hopefully sooner rather than later, I end up working in sort of an IDE for Azure Functions. Like literally what you see here is my Azure Function app, which is called AlexMang, and I can configure multiple functions within it. And I only have to click the plus sign, which obviously adds a new function. And the moment I do that, the wizard, hopefully sooner rather than later, do we have a better internet connection? Can you just like put steroids on my internet? It's so slow. You don't have a cable, maybe? Because I could work with that. Now, just look here. Is everything large enough? Can you guys in the back see? I'll try to make it a bit larger, but Chrome might crash eventually. Hopefully not. So there's a cable? Yes. Yeah, we can try it. Now, for doing this, I will probably have to sacrifice some memory for the demo gods, because otherwise it might crash. Let's try this. Fingers crossed. Hopefully no blue screens. So the first impressive thing here is that when I click on the language drop-down list, you'll see a bunch of languages I can choose from, right? And what language do you use and it's not here on the list? Maybe Java, but I'm sorry for you then. That's too bad. So I will choose C#, obviously, and I will just go ahead and, yeah, there we go. And I could specifically choose all the scenarios just to brag about how many templates there are, and you can choose among those. So there's a timer trigger, which is basically a cron-based expression, which just executes on a scheduled basis. Each 5 minutes, on each Monday, each midnight, whatever you want, it will just execute the function. And you're being billed by the execution. So you then have to pay for a 24-hour execution or 24/7 execution throughout the week or the month. So I could just go ahead and select, for example, HTTP trigger. I'm OK with the HTTP trigger C# free name. I'll just click create, and there we go. And I'm inside my editor right now. So what I have here is a template definition of the function code. There is a few files over here. And there is also a link called get function URL. And when I click this guy, I get the URL, which I can copy over, paste in over here. How much did it take for my function to be created? Almost nothing, and I already have a web server running, right? It's executing and it's returning an XML format, and I could also specifically use filter, for example, and say, get me a JSON format instead, because that's all configured in the system by default. And what I could do here, because it says, please pass a name on the query string or in the request body, let me just add a parameter called name and say Alex. When I do that, I get back the response. Now let's see how I can change the business logic of my application. What I'm going to do next is I would just change here a bit of the text, and I will say, hello, awesome crowd. Let's emphasize awesome. Awesome crowd at ITCamp from whatever the name is. And I could just click save. And I want to point out one thing. When I click save, it says script function has changed, we're reloading, and compilation succeeded. So just by changing the text, it compiled the thing. It's in a binary format for Azure Functions. So when I refresh this thing over again, I get the updated function. It's so easy, right? It's almost nothing, if you ask me. There is no publish, right-click, web deploy, configure FTP, blah, 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 things like that. So obviously, this is a very simple example. It's almost a hello world. So what we could also try to do, hopefully, eventually, you will not have your complete code in one file. You'll have multiple files. So let's try, for example, to add, oh, I didn't point this out, but my function by default is in a file with a CSX format. This is new. So this is C# script, more or less, because they think of this as a script now. But I'll use person CS. And I'll just define a new class. So I'll just say public class called person, and it will have a property, let's say name. So public string name property with a getter and a setter, and we're good. So what I'm going to do next, I will save this thing again. It will obviously compile it yet again. So how do I invoke in my CSX file the person file? Because see, there are no namespaces here, right? I will just say load, and then person CS. It's that easy. And the moment I do that, I will be able to use my person class. So for example, let me collapse this. I could instantiate a new person object of type person. There we go. And I could say the name property equals to whatever used to be the value over here. Oh, I want to try one more thing out. So I have specifically deleted the semicolon. I will save this guy over. And the moment I do that, it says compilation failed, because on line 17, we expected the semicolon to be there. So the error messages are actually pretty accurate, and it's not one of those programming languages where the error message has nothing to do with the actual error. So I added it, compilation succeeded, and when I click here, obviously the result should be the same, and there we go. So now I'm using other references from other files as well in my code. Number one question which I would personally ask is, okay, but what about NuGets, right? Because almost all applications nowadays use the NuGet package in one way or another. The cool thing about it is Newtonsoft, which ends up being one of the most popular NuGet packages throughout there, is already embedded into the system. So you can write NuGet code, and that's it. When you will reference your NuGet, your other namespaces or your Newtonsoft, you just say R from reference, and that's it. You can say Newtonsoft, for example. But in case of other references, there is this idea of a JSON file. And by the way, there are multiple JSON files. So I could have a project JSON file where I will say, use this NuGet package. And I can specifically choose the NuGet package version. And that means that when I will save the function from within the function app, it will automatically restore the NuGet package based on the definition I have given. So there is no problem or concerns about the entire publishing process either. The function JSON thing, though, is there to literally configure, like I showed you earlier in my slide deck, what the bindings are like. If you don't like JSON, shame on you. You can just go to integrate, and there's a UI which basically does more or less the same thing. Now, the first problem I personally had when I developed my first Azure Function application was, okay, so I want to use a blob, for example. I will obviously have a blob trigger because I saw that on the slide deck. But how do I know what type to use as a type of the object in the parameter list? Good thing there's a documentation which is actually pretty accurate and pretty comprehensive as well. So if I just choose here that my trigger will be of type of another type, whatever, or if I add an input. The input are extra parameters which will be sent out to the function when the function runs, when the trigger executes. I could say a blob storage, and when I select this thing, the documentation really reload and show me what configurations I should normally do, what the path should be like, so what a blob output code should look like, what objects I should use for JavaScript, for C#, whatever the case, and inside my function, what I should bind to. So it's not only a blob thing, it can also just as easily be a text reader, which literally means that Azure Functions will open the blob file, will start reading from it as a text file. It can be a stream, it can be whatever else, right? Make sense? All good? Good. The first, however, concern I usually have with this, and I will just cancel everything because I don't want that, is when you develop software, how often did it occur to you that by the time you go to production, you just type your code, never build, never debug, never do anything. You build and it's good for production. It never happens. You have to debug your code. You have to add breakpoints. Well, how do you add breakpoints in a web browser? You don't, right? So obviously, whilst it is very cool to do this, it's not the real world scenario, if you ask me, right? I'm not here to praise Microsoft or anything. I will every now and then bash them for what I do wrong, but they did nail this thing down because there is tooling for Visual Studio as well. So let's open Visual Studio. So within my Visual Studio, I will just go ahead. And by the way, this is 2017 update free, which is still under preview. You might ask me, okay, why are you using update free? This is being recorded? This is being recorded, okay. Hopefully the production guys will remove what I'm just about to say, because this is another cool story. So a few months ago, Visual Studio 2017 was in preview. It was a release client. There was Azure SDK 2.9 point whatever version, and there was Azure Function tooling supported right within as an extension, and it worked marvelously. It worked like a charm. And they also made it afterwards to work in Visual Studio 2015. Now, what did the big corporation do eventually? They decided on shipping Visual Studio 2017 with Azure SDK 3.0. And guess what? That's incompatible with the Visual Studio tooling. Fingers up, thumbs up, awesome. So up until like last week, the only option of using Azure Functions within Visual Studio was by using Visual Studio 2015, but that has changed. However, the most unfortunately thing though here is that they changed the tooling so much that the language a bit changes as well, and that will show you both scenarios. So, first, let's use Visual Studio 2017. I will open up Azure Functions. I'm creating a new function right now. I will just go ahead and click OK, and just to prove to you that it's only a function, I'll open up Solution Explorer. Oh, I should minimize, or actually maximize this thing somehow. There we go. Zoom in. So this is my function app. It has no functions within it whatsoever. There's a local settings JSON file, which is there to help me write environment variables, like a path thing in command prompt. So I could just right click. Did I give too much memory to the demo gods? There we go. So the menu context opened up. I'll just click Add New Item. And within my new item wizard, I can use Azure Functions. I'm okay with the function one name, because within the trigger, within the wizard, I also have to specify what the actual function name is. And that'll let's do the same thing. HTTP trigger, it's HTTP trigger C#, what the function name will be, create, and when I do that, it will just add a new function1 CS file. So it's not a CSX though. So when I open this guy, it's mostly, I will zoom out, right? And I will just make the fonts a bit larger. There we go. Why is everything with red squiggles? It shouldn't be like that. Let me build this thing and it should work. So basically, the difference here is the following. And let me just do it like this. First and foremost, there is this function name attribute, which is new, which wasn't there before. Yeah, whatever. Something isn't as it should be. Oh, yeah, I added. Thanks so much for that. Hawkeye. So, thanks so much, honestly. What the changes here are is that first and foremost, the method, the entry point is decorated with this function name attribute, which is new, right? That didn't used to be there, and it isn't in the Azure Portal either. Then all my parameters, like this rec thing, is decorated with this attribute. The reason for this is there is no function JSON thing within my application project. So rather than having the JSON, which does all the binding and gluing, which is more or less actually pretty difficult to understand and write by yourself because there's no IntelliSense in the browser, you end up using this thing, which is attributes for the parameters, and decorate everything. And it's way easier, if you ask me, from a personal experience, way easier to use, especially because you have IntelliSense as well. So if I run this guy, what will happen next? It will invoke the command prompt, basically on console application, and it will also invoke the Azure Functions CLI, the command line interface. And this thing over here will start with a famous logo of, there we go, boom, 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 Azure Functions. The next thing that it will do, it will literally mimic how Azure Functions works in production. Why is that? Well, remember, I'm not gluing anything together. It doesn't have any packages. It doesn't have anything like that. So it has to know how to execute this thing. I'm not running in IIS. I'm not running .NET Core. I'm not running a sandbox or a self-service environment IS thing. Yet I still have a listener over here. Nowhere in my code did I add the listener, right? So it's the runtime thing which does that. So if I were to open a new tab in Chrome, come on, there we go. I have the exact same response because it's the same template. So I could just add the parameter again, called name equals Alex, and there you have it. Now, the advantage here, though, is, as I mentioned earlier, you can just add breakpoints, refresh the thing, it will automatically go through, hit the breakpoint here. I can step over it, change the value afterwards, and say, hello, ITCamp, for example, and go through, and there we go, right? So it's the same software development experience you normally have everywhere else, and that's awesome. Now, what I will also do, just to prove to you that you can have as many functions as you like, in whatever language, by the way, I will also add within Visual Studio a new function which will do something else. This new function, however, will work on the wizard which does a face locator. The face locator basically will look for new blobs which are added to whatever Azure storage account, and it will try to figure out by using cognitive services where the face is inside the picture. Pretty impressive. So what I'm going to do next is I will use, within my local settings JSON, I mentioned earlier that there are environment variables. So there is one which is called Azure Web Job Storage. So I will just create the new thingy again. I'll just right-click, add new item, Azure Function. Function 2, awesome name, that's good. I will go with face locator, and sorry for the small fonts. And I'll just specify the connection string key name as being Azure Web Job Storage. Click Create, and there you have it, more or less. Come on, yeah, there it is, Function 2. So within Function 2, I have all the code, which is actually just a bit of it, which calls out the cognitive services service from Microsoft to figure out where the face is at. Now, obviously, for this, I will require something called a key. That key will be taken down from the environment variable. So let me just show you how you can add a new extra environment variable. I will just copy the key over, open up local settings again, and now let's give it some values as well. So it's a JSON format. There we go. So let's go back to the Azure Portal to get the actual values. I'll close these tabs. I'll go to my resource group again. And there you have it. So the first thing I will have to do is, this is my Vision API from Cognitive Services. I'll copy over the keys and the URL because that is actually changed from whatever is inside the template. Any questions so far? All good? So let me copy this guy over. Come on, copy button, where are you? There you go, click copy. Copied. So I will change that right here, because the URL, as I mentioned, has changed. And next, I will get the key from the Cognitive Service API. The keys are here. Please don't copy my keys. And I also should normally tell it what the connection string for my storage account is, so let's copy that thing as well. I will use, this is a good storage account. And I will just use whatever container there, which is, as far as I remember, called images. But we'll look at that. So, come on. There you go. Access keys. This is my Azure storage account. There you have it, the connection string. Just copy over, paste it here. Pretty easy, isn't it? Now, within function 2, as I said earlier, it looks for the images container, and they know that from within the blob trigger, which is the attribute of the parameter. So if I run this guy again, I will open up Azure Storage Explorer. And within Azure Storage Explorer, let me zoom in again. I will just copy over, I will just open up this particular blob container called images. And next I have some pictures of some faces somewhere around here. Yep, there we go. So I'll copy over these ones. Let the function run first, because I want you to see how it will normally work. By the way, because this is a development environment right now, it will not consume your entire CPU, which literally means there is a pooling processing system which will check whether there are any blobs added. It isn't the same in Azure Functions. In Azure Functions, it really literally works in real time. Here, because it doesn't consume all my CPU, it will have to wait for a bit. What does it say here? Oh, the connection string is missing or empty? I did save it, didn't I? In the wrong one? Oh, yeah, you're right. Thanks for that. So the system told me through the logs, by the way, how do you think this log appeared here? Anyone? It's actually because of, where are you? This guy. So you only have to add the parameter called log, and whatever you write inside that trace writer will be part of your logs, which can be stored in storage accounts or whatever the case. You can use application insights just as easily and create custom events based on that. So thanks for pointing out that I didn't copy the connection string there. Would have been a fairly bad demo otherwise. I will run this thing again. And as it runs, come on, I'm really out of memory here. Let me check that. Jesus Christ. Boom, 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 boom. Flames everywhere. Not enough. The question was, how much memory do you have? Not enough. The reason for why I'm consuming so much memory is that I'm actually running Windows Server 2016 on this laptop as well within the virtual machine, because there is another cool demo I want to show you. But there's only so much memory my computer has left. This is why it's so cool to run everything in the cloud, because you don't care about these things anymore, right? So it did realize that there are two functions, generating two job functions. It's listening for the HTTP trigger thing, and it also realized that there is the face locator thing as well. So now let's go back to my Storage Explorer. Let's open up, let's copy over actually these photos. And as soon as these will be copied, they will be analyzed by the function app. I'll go back here. And the output, the actual output is out table. Out table is the name of the parameter over here. And that's literally a list of face rectangles, and the decorator inside the attribute is table. So within an Azure Storage Account table, it will just give me the results of my analysis. So, Jesus Christ, this isn't going as expected. Object reference not set to an instant of an object. Okay, something is clearly not good. So I will just ditch this as it is right now. I'm not focusing on it anymore because object reference not set to an instant of an object. But it still worked, because this is a fresh data. So it's in GMT format, it's 1126, it still worked. Like the best code ever is the one which you don't know why it worked. So what you see here, however, is the fact that for each and every single file I added, I see exactly where the face is at inside the picture. So that's good. It's the expected result. Now, yeah, we're not only abstracting away the fact that we no longer use servers, we're abstracting errors as well. Good. It's a feature, it's not a bug. So let's move on from there. There is one more thing I want to show you, and that is actually a couple of things. I will use this. This is a virtual connection towards another VM, which is running Visual Studio 2015. And I wanted to show you this as well, because a few months ago, one thing people don't know about me is that when I was a kid, I was a huge Pokemon fan. And a few months ago, yeah, don't laugh about that. A few months before actually delving into the Azure Functions world, I wanted to create an application which uses cognitive services again and creates Pokemon cards with human beings, which is like the best thing ever. Now, cognitive services is using the emotion API, which literally means that I can take my phone out, take a picture of somebody, and tell whether they're happy or angry or whatever the case. So I created an app for that. Now, the reason for why I wanted to share this information with you is that the next demo is me trying to use the same application, which used to be a website, so I was paying for it to run continuously, even though I was only using once per month. So, right, so it was super expensive. I wanted to use Azure Functions for that. And here's what I did. And this is actually pretty impressive for current running workloads. So this is my application. What I had to do, actually it's pretty easy. This is my C# card generator class. I had to add the main entry point. But see how I'm not using any attributes, nothing. It's just a static method within the class, that's it, right? And it's called run, but I can call it whatever I want. So what I'm going to do next is I will recompile the file. I'll open up my favorite browser. Not. Wasn't that obvious? I'll open up this function application again called AlexMang, and I'll create a new function app out of that. So how did my DLL file end up working as a function? Let's see. So I'm just specifying here, this will be triggered by a blob again. I will hit create and see how it automatically added both the CSX and the function. Neither of these are good for me, right? Like literally they're no good. So I will just upload the DLL I have created from my build process, click open. You don't have permission. How is that possible? Like, I swear I did this a dozen times. I don't have permission. This is the new file, isn't it? Let me copy it over to the desktop, whatever. And at least I proved to you that I'm not lying with this. What? I don't have admin rights on my admin machine, on my VM, on Azure. I hate this. What's that? With my admin user? Advanced? This really is not working as I expected it to, and it worked like 10 minutes ago. Unable to... You don't have permission? Hey guys, I think I'm WannaCry hit. Let me think of a solution really quick. So this is the admin which is running Visual Studio right now. Yeah, I'll change the output path. It's exactly what I wanted to do. So build, where's that? Build events? No, it's build here. Output path, desktop, select folder. Maybe I should use whatever other folder. COD sounds good for code. Dermon, rebuild, build started. Okay, let's hope for the best. So back to the desktop, COD, Codermon cards. Okay, we're good. It's uploading, so that's good. Now the next thing I will have to do is change the function JSON, and let me show you how I'm doing that. So I just go straight down here, and I'm pasting this from the clipboard. Okay, there's access, so that's good. I'm pasting this thing over. So what you see here, hopefully, let me zoom in a bit. What you see here is that I added two special properties within my JSON file. One is the script file, codemon cards DLL, and the other one is the name of the namespace, class, and method I want the function to run. It's blob triggered, like literally means that the direction is an input based on the blob trigger thing. So whenever a new blob will be added, it will just run the thing and create the Pokemon cards for human beings. So how does it work? It looks into the input container between percentage signs. What's that? It's a special scenario where I'm telling it within the JSON file that I want it to look for an environment variable. Oops, sorry for that. An environment variable called input container. So if I go back to Azure Functions app, I have to save it. And I will also do one more thing. I didn't try this out before, so this is pretty nifty to do. I'll just delete the CSX file. So literally, there is no other entry point besides whatever I have defined, part of my DLL. So it will decompile the DLL. It will look where the entry point is based on the intermediate language of C#, and that's it. It will just run the code. So let's see how it works. I will open up the log thing over here. I will expand it, see how it saw that the assembly has changed, and it restarted the host. It did whatever it had to do. And now, I'll just use Azure Storage Explorer. I have my Storage Explorer over here. I'll use card input, which is the name of the container defined as an environment variable thing. And inside card output, I should normally have my Pokemon cards. So let's just try that. I'll take the same faces yet again, paste them over. They're being copied. As soon as the copy process finishes, I should see the function to start running. Yeah, function started for each and every single blob. So even though it didn't finish, it starts as often as it's required. So you can have 1 million requests, just like I said. It will just process them all, right, in the same time. So let me go back to my Azure Storage Explorer, card output, and refresh. And there we go. Here are my card outputs. So let's see, for example, the second one. It will just download it first from my Azure Storage account. And come on. There you have it. Angry Microsoft engineer. Expect snarky comments in your code review. Let's try another one. The third one. Another angry Microsoft engineer. So the cognitive services did the job. Azure Function did the job as well. It just worked like a charm. Mona Lisa, neutral Microsoft engineer. Neither happy nor sad, pre-prepared to show prototypes and data. Let's see a happy one, a surprised one, if we get lucky. So fifth one, download. Boom. We're almost there. Yeah, happy Microsoft engineer. Now's the perfect time to cash in a big favor. Awesome. So I did mention Windows Server 2016 before. Why did I do that? Because there is a world, the world we live in actually, which is pretty unfortunate because we leave our computers open. We leave them running for the night, for whatever, and it's idle. So the Microsoft team, what did they think? They decided, let's make a system where we're using the idle processing power for you to run your functions on premises. And when you need your processing power back, you just stop the function and it runs somewhere else, in the cloud, for example. It's the same piece of code running on premises. So what I did, just to prove to you that I'm not lying here, I created my Hyper-V machine. Where are you at? Here. Which is running Windows Server 2016. There you see the name of it. Wonderful. And let me open up the connection. And within my function, and sorry for the small font yet again, I have, what you see here is Internet Explorer connecting to IIS locally on that machine, which also has SQL Server Express installed on it because of the tooling. And this thing right now will allow me to create any new function. There is a cool thing about it. Come on, memory. I will just have to close things down. Visual Studio is already closed. What else? Chrome. No brainer. Yeah, memory went down a gig, so that's good. Plus, no nothing. Yeah, you can take my word for it. Yeah, this isn't. Oh my God. Yeah, I have to buy a shiny new Surface, I think. Lenovo, just like Tootie said yesterday in his security demo, Lenovo is not trustworthy. Okay, so take my word for it. If I click plus, I get the same experience there. I can publish my functions, and everything is cool and nice. And besides that, I also get, how many of you have ever used SQL Service brokers in your life? Okay, there's one hand. So basically, SQL Service Broker works when there is a change within a table, within whatever database is. That can be a trigger for your function to work as well. And you just configure your function that is based, the trigger is based on your SQL Service Broker, and that's it. Good. Developer experience, same thing, blah, 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 administrative features. And there are two types, and I tried to make the demo, so I think we still have like 5 minutes for questions. Anyone?